Assalamu alaikum students. We start our third lecture on thermodynamics. The topic under study is the Kirchhoff equation. This equation tells us the effect of temperature on the heat of reaction, and the heat of reaction changes with the specific heat. So this equation can be calculated both at constant pressure and at constant volume. First we will study the effect at constant pressure. The enthalpy change of a reaction is given by del H is equal to enthalpy of the product minus the enthalpy of the reactants. Partially differentiating this equation with respect to temperature at constant pressure. As I have already told you, W is for with, R is for respect, and T is for to. So at constant pressure we get partially differentiating del H with respect to temperature at constant pressure is equal to partial H by partial T at constant pressure of the products minus partial H by partial T of the at constant pressure of the reactants. As we know, partial H by partial T at constant pressure is equal to Cp. Cp is the specific heat at constant pressure. So we will put the value of Cp at this point. So partial del H by partial T at constant pressure is equal to Cp of the products minus Cp of the reactants. Subtract this one. So partial del H by partial T at constant pressure is equal to del Cp. This is called the Kirchhoff equation. This equation tells the change of enthalpy with respect to temperature. But if we want to know the change of enthalpy for a particular change of temperature, it means between two limits, then we integrate the equation 2 between the limits. Let us suppose that at temperature T1 the enthalpy change is del H1, and at temperature T2 the change of enthalpy is del H2. So we integrate the equation, we will integrate this equation. But as we know that for integration we will change this partial factor to partial differentiation factor to the full differentiation. This is the sign of differentiation and this is the sign of the partial differentiation. I've changed this partial differentiation sign with d. So d of del H by dt is equal to del Cp. Bring this del dt at this point, the equation will become d of del H is equal to del Cp into dt. This dot indicates the multiplication. Del Cp into dt. This will become the equation number 3. Now integrate this equation between the limits del H2, del H1 and temperature between T1 and T2. 2 sign, as I have told you, that 2 sign indicates the final state of the system. So del H2 is the final state and del H1 is the initial state. Similarly, T2 is the final temperature, T1 is the initial temperature. And I have told you that for integration, we integrate only the variable factors. Del Cp is supposed to be constant over temperature range. So we will bring this outside this integration sign. To solve this integration, the result of the del H by mathematical calculation is H, d of del H. So d of del H is del H. Put the limits del H2 and del H1. Similarly, C is equal to Cp dt. Result of integration of dt is only t. Put the limits T2 and T1. Del H2 minus del H1 is equal to del Cp T2 minus T1. Del H2 minus del H1 is equal to del Cp into del T. This is the result of the Kirchhoff equation at constant pressure. Similarly, we can do this equation at constant volume. The change of internal energy can be written as del E is equal to internal energy of the products minus internal energy of the reactants. So we will solve this equation like at constant pressure we solved it. So the result of this equation will become, after the calculation, del E2 minus del E1 is equal to del CV into T2 minus T1. Here instead of Cp we write del Cv. Similarly, instead of del H2 we will write del E2 minus del E1. So T2 minus T1 is equal to del T. The equation will become del E2 minus del E1 is equal to del Cv into del T if Cv is constant. So equation number 2, 5 and 6 are the different forms of the Kirchhoff equation. As I have told you, this equation shows the effect of temperature on heat of reaction. The next topic is first law of thermodynamics. There are various forms to describe this first law. The first definition is energy can neither be created nor be destroyed, although it may convert from one form to another. It means nature accepts no laws. Total, or we can say that total energy of the system and its surrounding is conserved. Conserved means महफूज होना. To understand this law quantitatively means mathematically we will study that when we consider a gaseous system, when we supply the heat to the system, a part of heat, it means some heat will be used to increase the internal energy and some heat will use to do the work. As we see, always notice that when some mechanical work is done by any electrical appliance, it will heat up. This heat up indicates the change of internal energy or increase of the internal energy of the system. And mechanical work is shown by the work done. So mathematically it can be written as Q heat supplied is equal to change in internal energy plus W work done. Change in internal energy E2 minus E1 is equal to del E. So bring this del E here. Del E is equal to Q minus W. For infinitely small chain, as I have told you, del is always used for larger changes, D is used for small changes. For infinitely small chain, dE is equal to partial Q minus partial W, or dE is equal to partial Q minus PdV. As we know, W is equal to PdV. In thermodynamics, the only work done is pressure volume work. So pressure volume work is described by PdV. Work done by the system is negative. So latest sign convention shows for this work that work done by the system is put as a negative sign. So we will write negative with this PdV. So this will become minus PdV. This minus is from here. dE is equal to partial Q minus PdV. Minus multiply, it will become plus. dE is equal to partial Q plus PdV, or del E is equal to Q plus W. This is the mathematical statement of first law of thermodynamics. Next our topic is the enthalpy. I have told you the definition of enthalpy. Now I will describe it. The total heat content of a system at constant pressure. Always remember that you will take the enthalpy always at constant pressure. This is called enthalpy. It is equivalent to the internal energy plus pressure volume work. Pressure volume energy. It is denoted by H. A change in enthalpy del H of a system can be given as del H is equal to del E plus del PV. Del H is equal to del E, multiply this del with PV, so del PV plus P del V. Del P into V plus P into del V. At constant pressure, del P is equal to 0. So del H is equal to del E plus multiply this del P 0 into V, so it will become 0 plus P dV. del H is equal to del E plus del P del V. This is the equation of enthalpy change. According to first law of thermodynamics, del E is equal to Q plus W. So substitute the value of del E in this equation. Del H is equal to Q plus W plus P del V. Del H is equal to Q minus P del V plus P del V. Del H is equal to Qp at constant pressure. So thus the enthalpy change is equal to the heat evolved or absorbed at constant pressure. And there exists a relationship between del H and del E. PV is equal to nRT according to general gas equation. PV is equal to nRT. Multiply this equation with del. So del PV is equal to del N into RT. We will not multiply RT with del because they are constants. So put the value of del PV in equation number 2. This one, del H is equal to del E plus del N RT. Del H is QP. Del E is equal to QV plus del N RT. I think you all have carried it. Understand it. Thank you.